Salam and welcome everyone. So today we're going to be working on the question on the screen that says estimate the change in Gibbs energy of 100 centimeter cube of water when the pressure acting on it is increased from 100 kilopascal to 500 kilopascal. Given that the mass density of water is 0.97 gram per cm cube, determine the change in molar Gibbs energy. So we're asked to find estimate the change in Gibbs energy. So this is what we asked to do. And then of 100 centimeter cube of water. So we're told the volume of water is 100 centimeter cube. Okay. When the pressure acting on it is increased from 100 kilopascal. So we have from, meaning there's an increase, is increased, right? From, meaning there's an initial value for pressure, okay, to 500 kilopascal. So there's a final pressure value. So that will be 500 kilopascal. Given that the mass density of water is 0.997 gram per cm cube, so mass density or basically density is 0.997 gram per cm cube. We're also told to determine the change in molar Gibbs energy. So this question is two. We have to find the change in Gibbs energy as well as the change in molar Gibbs energy of reaction. Now, the first thing you have to note is this. We have a question where we are meant to find the Gibbs energy and molar Gibbs energy. And for anyone who hasn't really studied well or might be confused, you have to note that the change, okay, in molar Gibbs energy is the same thing as the change in Gibbs energy divided by the number of moles. That is basically what this is. So, when you find the change in molar Gibbs energy, you can always find the change in Gibbs energy. And if you have the change in Gibbs energy, you can always find the change in molar Gibbs energy, provided you have the value for number of moles. So therefore, the change in Gibbs energy, okay, is the same thing as the number of moles times the change in molar Gibbs energy. So this equation that you're actually looking at is what the relationship between the molar Gibbs energy and the Gibbs energy is. So this particular equation. Now that we have that information, we can go back to the information that we're given. We're told the initial pressure, the final pressure. We also told the volume. And in this question, they did not tell us that we're dealing with an isothermal problem. So we're going to be using this particular equation to solve this question. The molar Gibbs energy of at the final pressure, okay, is equal to the molar Gibbs energy at the initial pressure, okay, plus the molar volume multiplied by the P final minus the P initial. This is what we're supposed to use. We have the value for initial pressure, okay, we have the value for final pressure, we have the value of volume, but we don't have the value for molar volume, which is basically Vm. This gives energy at the final pressure and then gives energy at the initial pressure. We can rewrite this formula this way. The change in molar Gibbs energy, the molar Gibbs energy at the final pressure minus the molar Gibbs energy at the initial pressure, okay, is equal to the molar volume times P final minus P initial. So the change in molar Gibbs energy, okay, is going to simply be the molar volume times P final minus P initial. So this is basically the equation that we're going to use in solving this question. Now, the next thing you're going to note is this. We're given volume in the question, but not molar volume. But we're also given density in the question, right? Well, we have to remember that the formula for density is what? Density is equal to mass over volume, right? So density is equal to mass over volume. When you cross multiply, what you end up with is mass is equal to density, okay, times volume. So what this is simply asking us to do is that we're going to go from just the density and the volume to discovering what the mass is. So you have this one right here. You have 0.997 gram per cm cube. So 0.997 gram per cm cube, okay, times the volume that we have. And the volume we have in this question is 100 centimeter cube. So times 100 centimeter cube. Of course, we do the cancel out. So we have 0.997 grams times 100. You end up with the mass 99.7 grams. Let's not forget that in order for us to go from volume to molar volume, we have to have the volume divided by the number of moles to give us the what? The molar volume. So this is how it's done. Now we have mass, okay? We have the mass. Now you may be wondering, why do we have the mass? Well, because we have to determine what the number of mole is so that we divide we use the volume to divide the value for number of moles in order for us to get the molar volume, so that we can properly input it in this equation. So we're going to need the value for molar volume to be able to properly substitute. So now you have the mass. Well, one thing you need to also remember is the number of moles, okay, which is what we're trying to calculate, is the same thing as mass over molar mass. We've got the mass, right, which is 99.7. We know the molar mass because the molar mass of water can be calculated. So the molar mass of water, we know that to be 18.06 gram per mole. So that would be 99.7 grams, okay, divided by 18.06 gram per mole. And the reason why I don't think I need to calculate the molar mass of water is because this is an advanced chemistry course. So at this particular point, people already know how to solve molar mass. So we cancel our grams, 99.7 divided by 18.6 is going to give you the number of moles to be 5.52049 mole. So this is the number of moles is just basically 5.52049 mole. So this is basically what we're going to be using. Now, the work is not even close to being done, right? Because this question is actually would actually require much more complicated solution, but not difficult, just a little bit more complex. Not complicated, I apologize, complex. So rewriting our formula, let me rewrite it here so I don't have to go back and forth. Rewriting our formula, we know the change in molar Gibbs energy is what? The molar volume, okay, multiplied by P final minus P initial. Well, the molar volume, we still don't know what that is, but we have the number of moles. And we have to remember that the unit for change in Gibbs energy, molar Gibbs energy, is what? Joules per mole or kilojoule per mole. Note that when you find joule per mole or kilojoule per mole, you can either multiply by 1000 or divide by 1000 to go from either kilojoule per mole or joule per mole. So don't overthink it. But we have to remember that this question now, where we're given the molar volume as well as the pressure. We have to make sure that we use the values in which the units match in such a way that when we cancel out units or when we use our units, we're going to end up with joule per mole. We're going to end up with joule per mole. So, for example, you have molar volume. Well, when we think about the SI unit for volume and how we can go from the regular parameters that we're given to joule per mole, we have to remember that the unit for volume is meter cube. Now we have molar volume, so we can say meter cube per mole, okay, times the unit for pressure, right? The unit for pressure is simply a bunch of different things, but we need the unit for pressure in such a way that we can manipulate it to get joules per mole, and that is simply Pascal. And another thing for name for Pascal is the same thing as Newton per meter squared. That is it, because pressure is the definition of pressure is force over area. So the units for force is Newton, the units for area is meter squared when you think about SI units, right? So simply cancel out meter squared here, cancel out meter squared in meter cube is just m. So we end up with Newton meter divided by mole. Remember, Newton meter is the same thing as joules, okay? And then you just have mole. Newton meter, the reason why it's joules is because the unit for energy or work done is joules, because what is the formula for work, right? Force times distance, and the units for work is simply joules. So we can just say Newton meter is the same thing as joule, and then per mole will be joule per mole. So this, what I'm trying to tell you is that we have to convert our molar volume to meters. What I'm telling you is that we have to convert our molar volume to meter cube per mole, as well as the pressure to be either Pascal or to be in Pascal or to be in Newton per meter square. It doesn't really matter. So I'm just telling you that this is what we're going to use. So we're not going to be using any dm cubed, any atmospheres, any bars, or any mmHg, or any centimeter cube. We're going to have to convert from whatever we have to what we need in order for us to get our units for change in molar Gibbs energy to be in joule per mole. So this is how it's done. Anyways, that's the important information that you have. Now, let's go back to the volume that we're given. 100 centimeter cube. Let me just do it on the side here. 100 centimeter cube, right? In meter cube is going to be what? Well, let's not forget that we note this, that 1 meter, okay, is the same thing as 100 centimeter. Then 1 meter cubed is the same thing as 100, okay, centimeter cubed. 1 times 1 times 1 is 1. Meter times meter times meter is meter cubed. I'm writing the fundamental information. 100 times 100 times 100 is just simply What is it, you guys? What is it? You have 100 times 100 times 100. So you have centimeter cube. So what you end up with is 1 million centimeter cube. And then you have 100. Our question gives us 100 right here. So we're just going to have 100 centimeter cube. I'm using proportionality method to be able to solve this. Let's just call this X for our unknown. So that would be 1 million centimeter cube X is equal to 100 centimeter cube decimeter cube. So of course, cancel centimeter cube here, cancel centimeter cube here. So what you end up with is X is equal to 100, okay, decimeter cube divided by 1 million. So of course, cancel this out, cancel this out. So you have, so X is just going to be 1 times 10 raised to the power of negative 4, okay. Oh, sorry, not decimeter cube. Gosh, the way the devil really wanted to mess this up for me. It's not decimeter cube. We have meters cube. So this is going to be meter cube here. So 100 divided by 1 million is the same thing as 1 divided by 1 divided by 10,000 meters cube, which is the same thing as 1 times 10 to the power of negative 4 meters cube. Of course, we know that this can be divided by the number of moles. So that's going to be divided by the number of moles. So basically, this is the volume, right? Divided by the number of moles, because we're trying to go from volume here to molar volume. So this would look like the molar volume is going to be volume divided by number of moles. So that would be 1 times 10 raised to the power negative 4, okay, meters cube divided by the number of moles, which is 5.52049 mole. You guys can already see that this question is quite complex. So don't worry. At the end of the day, it's gonna make sense. I'm gonna do like a short review. So 1 times 10 to the power negative 4 meters cubed divided by 5.52049 mole is gonna give you 1.8114 times 10 raised to the power of negative 5 meter cube per mole. Okay, so that's it. Now, of course, you have P final minus P initial. You have the P final to be 500 kilopascal or 500,000 pascals. We already know Pascal is the same thing as Newton per meter square, so we actually don't need to do any. We don't need to we don't need to manipulate anything. So I'm just going to rewrite the equation. Change in molar Gibbs energy is going to simply be molar volume times P final minus P initial. So that would be change in G. Remember, Pascal is the same thing as Newton per meter squared. So let's not worry about that. We're just going to simply substitute for pressure because we don't actually have to convert the units at all. It's at the proper units that we want. So we have 1.8114 times 10 to the power of negative 5, okay, meter cube per mole, okay, times, so that will be, final pressure will be 500,000 Newton per meter square. So that'll be 500,000 because 500 kilopascal is the same thing as 500,000 Newton per meter squared, okay, minus the initial pressure, which is just 100,000 Newton per meter squared. So that's how it's done. So you have changing G of M to be 1.8114 times 10 to the power negative 5 meter cube per mole times 400,000 Newton per meter squared. Okay, cancel out meter squared, cancel out meter. So you have 400,000 times 1.811 times 10 to the power negative 5 would give you 7.245 3 Newton meter per mole, or you can just simply write 7.24573 joule per mole. That's basically the answer. Now, I want to quickly mention something to you guys. The thing I want to mention is that because we're dealing with a question in chemistry, we have to put in the proper number of significant figures. And we have to look back into our question and see the number of significant figures for the numerical values in our question. So we have 100 kilopascal. So that's 3 sig figs, 3 sig figs, 3 sig figs. So that means our final answer would have to be in what? 3 sig figs. So the change in molar Gibbs energy was going to be 7.25 joule per mole as the answer to the question. Now, I wanted to also mention something. So, if you go back to our question, you notice that we're not simply asked to find the change in molar Gibbs energy. We're also told to estimate the change in Gibbs energy. Well, if you remember what I taught you, the change in Gibbs energy, okay, is the same thing as the number of moles times the change in molar Gibbs energy. So that'll be the change in Gibbs energy is now simply going to be the number of moles. We know that to be 5.52. Know that to be 5.52. I'm trying to look for it to be calculated. 5.52049. 52049, okay, mole times, we're going to use the raw value. I'm not going to use the approximated value. The raw value is the way to go in chemistry. So times 7.24573 joule per mole. Cancel out the mole. Cancel out the mole. 5.52049 times 7.24573. So the change in G is going to be simply 40 joules. And this is basically the answer to this question. Basically, exactly 40 joules. So, yeah, this is the answer to this question. If you have any questions, please put in the comment section. If you have any concerns, also put it in the comment section. If you have a suggestion, also put it in the comment section. Now, to keep my promise, I'm just going to quickly do the short review of what we did, right? So, the question asked us to find the change in Gibbs energy as well as the change in molar Gibbs energy. So, the first thing we did is for us to determine the formula we're supposed to use after we've brought out the parameters. We then determine the formula that we're going to use that to as the relationship between Gibbs energy and molar Gibbs energy. We have the formula we're supposed to use. Next, we have to determine the units that would work for this formula to work properly. So we notice that the unit for change in molar Gibbs energy is just simply joule per mole. So we had to manipulate the unit for volume to go to be in terms of whatever we are going to manipulate to get joules per mole. So that means we had to change from 100 centimeter cube for our value to whatever that value is in meter cube. And we know that value to be 1 times 10 to the power negative 4. So now we had the units for volume. We had to remember that the formula required us to use molar volume. So we have volume, and then from volume, we divided volume by number of moles to get molar volume. Now, to be able to even find the number of moles before molar volume, we're given the value for density. We have the value for density as well as value of volume. We're able to find the mass. And from the mass, using the molar mass, we're able to find the number of moles. So that was the number of moles that we used to determine the molar volume. So we have pressure. Pressure, thankfully, it was in the units that would make our question work well. So we just simply substituted. And when we substituted, we did the calculation to get 7.25 joule per mole for the value of change in molar Gibbs energy. But then we also have to solve for the change in Gibbs energy. And then we used our formula, change in G equals number of moles times change in GM. And we've determined the change in Gibbs energy. So that is basically what we did. If you're a student who is struggling in any of your STEM related courses and you're trying to succeed, make sure you email me at shohappytutoring@gmail.com. I help middle school, high school, and college level students to succeed and be the best version of themselves in academia. You can also email me for mentorship services. I help students succeed in other areas of academia besides tutoring. So I wish you guys all the very best, and email me at shohappytutoring@gmail.com. Assalamu alaikum wa rahmatullahi wa barakatuh.